Okay, so we'll start off talking about characters and strings. And the first thing we'll talk about is the character. So character is our seventh primitive. All right. Fundamentally, a char is a number that gets printed as text. If you want like one sentence to describe what a char is, it's that. It's a 16-bit integer, like a short, but it's used for mapping to char set classes. And because of that, if you look at these character set classes, if you go down to the Windows System Tools, for example, you can see the character map, the Windows Accessories, System? Where's my font? Character map. There it was, right where I thought it was. I just missed over it. Okay, there is a character map. Each of these characters has a specific number associated with it. For example, A starts at number 65, which in hexadecimal, if you see here, 0041, that's 4 times 16 plus 1, 64 plus 1, 65. Likewise, lower cases start at 97. So if I click on lowercase a, 0061. 6 times 16 is 96, plus 1, 97. So all of the values for characters are mapped to whatever font you're using. And this creates a problem because all of these numbers are non-negative. So a char only holds numbers from 0 on up. Unlike a short, which is plus or minus 32,000 and change, a char goes from 0 to 65,535. It's all positive. So it's a little different. So even though short and char, they're both 16-bit numbers, the number values they can hold are a little different, and so you can't just typecast directly from one to the other. Okay, fundamentally, a char is a number, and because it's a number, you can do addition and other arithmetic operations. You can add to it, you can multiply it, things like that. And you can do comparisons, which is very useful for sorting letters alphabetically. So you can say, is 97 less than 98? Is a lowercase a less than lowercase b? Yes, right? If you're just talking about text, it wouldn't really make sense to say, is a greater than b? They're letters. They don't do that kind of comparison. But since characters are numbers associated with letters, you can do that kind of comparison. Okay. In text, if you're showing one as a text, it gets signified by one character in single quotes. For example, if you tell Java to print out the character lowercase a, that's how you would do it, an a inside of single quotes. So we'll do a new class. We'll call it, I want to do a different project. So fun with chars. We'll make our main method. Boom. Okay. And if we want to print out a character, so print a lowercase a to the console. Okay. System.out.println lowercase a inside of single quotes. And it'll get there someday. It'll tell me it can't load the library. Whoop. Okay. Boom. So we run this. Yeah, that library can't get it. I get it. Fine. Boom. And we get our lowercase a. Okay, because that's what a character is. It is a number that prints as text. Okay, so a little more with the slides. Typecasting. So remember, char is fundamentally a number. So typecasting from char to numeric types is valid, right? You can say, okay, I'm going to take this number that is a char, and I'm going to convert it to something else. But typecasting from char to a string is not valid. It's a common mistake. So a string is an object that contains a bunch of characters, but fundamentally, string is an object, character is a number. It's like you're trying to convert 97 to some slug of text. It doesn't work. So if you want to convert a char to a single character string, you can use other techniques. You can use concatenation or some primitive classes, which I'll talk about in a little bit. So for example, this case, if I try to do string a equals a, it's not valid. I get the thing that says type mismatch, cannot convert from char to string. But I can do this. I can do concatenation with an empty string, right? A zero-length string here, which we'll talk about in the back half of this lecture. Okay, and I can concatenate that with the a. And here, again, and print out the same thing. So concatenate and print the string A. Okay, and this works fine. Then this one I also, okay, I get the second A, because with concatenation that works. Okay, yes? Yes. Remember we talked about how mixed expressions work with numbers? That the result is always the higher precision type? Same thing, okay? This is a string, this is a character. In a sense, Java regards a string as a higher precision type, and it combines the two into a string. It's the same principle, but the mechanics are a little different. Okay? Does that make sense? Okay. All right. So, syntax for a string. Char variables declare the same way as all these other numeric primitives. If we want to call C a variable of type char, we just declare it as char C. And we can assign it in two ways. Number one, you can do it as a number, or number two, you can do it as a literal character. Either of those is perfectly fine. And so this, you can learn some mathematical operations, right, to do quick conversions. So uppercase starts at 65. If you add 32 to it, 65 turns to 97. 97 is where the lowercase ones start. So converting uppercase to lowercase, add 32. Likewise, convert lowercase to uppercase, subtract 32. Okay? Quick, easy conversion. So, and that's really it for characters. I'll do a little demo on this, right? So let's do, we can put in a method. Void method. We don't really care. There's really nothing here. For example, if I do char C equals 65, and I print it out, it's going to print out a capital A. Okay? So I'll say here, declare char C, assign value A by number. Okay, so if I call, make that static. Call method. Okay, if I run this one now, it's going to print out that 65, or it's going to print out the uppercase A from character 65. Okay, because it fundamentally is a number. If I add 32 to C, C plus equals 32, and I do the same thing, right? That's fine. Convert to lowercase a by adding 32. Okay, also perfectly fine. And then I print that out, and boom, we get our lowercase a again. Okay? So that's it. That's the key takeaway. A character is a number that prints as text. Yes? I've been doing this for a while. I don't expect people to remember that, okay? That would be crazy Java trivia. Yes? Okay. Well, remember I brought up this character map, right? So in this character map, this is the basic one, right? This is the standard one that Java uses. This capital A starts at number 65. And the next one is 66 and 67 and 68 and so on. Likewise, lowercase a starts at 97, goes to 98. So if I have 65 here, I want to convert it to lowercase, I add 32. Because that's the way the characters are mapped. 65 plus 32 brings me to 97, which is that character. And it's arranged that way on purpose. Okay, it was arranged in a time when there were only 256 characters because there was just, a simpler font in those days. But that's the basic idea, is to allow quick conversions and do things like avoid being case sensitive. Keeps the math simple for that. Yes? A string contains multiple characters. So a string is an object that contains an array of type char. But the array is private and you can't get to it directly, but that's what's in there, is a sequence of type char. Yeah. I mean, not all of these, but is, a stack of char variables. Yeah. Yeah. That's me.
So these are basically numbers. If you use numbers and you get a character at the end.
Yeah.
How do you use a string to do that?
A char is a number. Okay, a string is something different. A string is an object that uses chars.
At the end result, when you're printing or getting the return, it comes as A, B, or like.
Yeah, but my point is a char is the building block of a string. You can't really have that data in a string without the char.
But that is back in the view.
Yeah, I mean, we'll talk about some of that eventually, but yeah, some of those details are hidden from us. But without type char, basically string doesn't work, or it doesn't work nearly as easily. Now, I'll do one, yeah, go ahead.
Can you use like other operations for converting the like uppercase or lowercase? For instance, like using a module, but it's
You could write your own code, right? For example, if you had a different character mapping, you would do something different, right? Or if you had, there are languages that have more than 32 characters, in which case it wouldn't make sense to do a plus 32. There's no way that's going to work, right? Or there's no simple way that's going to work. So yeah, you could come up with your own custom thing, but if you're doing stuff in English with the basic, font, then yeah, this character mapping, the plus minus 32 works for that. I want to show you one last thing. I'm going to do this in code, and then we'll have the quiz. So, last thing. Okay, what do we want to do with a char? Let's try to convert to a short. Okay, convert char to other types. Okay, so for example, if I have long L equals C, it says that's okay, right? Any value that's contained within a char, I can contain in a long, and long is plus or minus 9 quintillion, whereas a char is 0 to 65,000. Every variable representable by a char can also be represented exactly by a long. Likewise, int I equals C. There's no problem, same thing, right? But if I try to do short S equals C, it doesn't like that. I get the error. It says type mismatch cannot convert from char to short. The fundamental reason, right? Char, they're both 16-bit integers, but char is all non-negative, so not every value in a char could be contained in a short. Because, for example, if I try to do 65,500, 65,535, which is the biggest number you can have, short's not going to tolerate that. What I can do, though, I can typecast it. And if I typecast it, then yeah, it's going to take everything that's over and get rid of the rest, right? So basically, it's going to do an overflow. It's only going to keep that, the 16 bits that the short actually uses. So 15 bits for the number, and then the 16th one for the sign. All right. Okay, so that is what we would have to do, and I can do typecast as well with C, and that works. So I'll say must typecast for short or byte. Okay, and that's type char. We'll come back on Wednesday and we'll review the quiz, and I will have stuff to say with strings. Okay, so please